So let's now see that how to find a periodic equation from the given graph here. So you can see that this is a graph. This graph is this graph looks like of as if this is of tan x or negative tan x, for example. So what can we do here is that you can check this out. If this is if this graph would be the graph of tan x, your curve would be like this, and concavity would change about this point. All right, so this is a graph of tan x. Okay, and if you suppose as y equals to minus tan x, then its graph would be like this. It means this part would be reflected about y asymptotic line. So you can see this part of the curve has equation, this whole equation. So if this is tan x, then the equation for this curve is negative tan x. It's so that minus tan x, y equals to minus tan x means it's so that the curve has the curve is reflected about y axis. It's okay. But here in this case, another feature you can see that in this case the curve has period pi. All right, but what happens if the curve has period pi by 2? That means the same sort of nature it will show by the line, because when this is tan x, the period is pi. When it is tan 2x, for example, then period will be pi by 2, and hence at pi by 2 the curve shows asymptotic nature. So instead of that, the tan 2x will show asymptotic nature about this. So if we are talking of tan 2x, so this would be the curve, and it will show asymptotic nature about x equals to plus minus pi by 4. So this is the equation for tan 2x. And if you reflect this image about y-axis, then what happens in that case? Your curve will look like this. It goes near and near to this line, and then another line, this near to this line, but it never touches the line x equals to 4, and it has equation minus tan 2x, that is y equals to minus tan 2x. So this is something like this. It looks like as if of this curve is of minus tan x, or y equals to minus tan x, or it might be y equals to minus tan 2x if the period is pi by 2, and if the period, if you find here as period as pi, that means it could be of negative tan curve. All right, so anyway, this is going to be tan curves, that sort of thing we are sure of. Now let's see further about that. You can see here that concavity, if I'm talking this curve, the concavity has been changed at this point. It's okay. So for its 0 point, if you check, the concavity doesn't change here. So that means it seems to change from here. So first of all, write down one equation, y equals to a tan bx plus c plus d. So if you can get the values of a, b, c, and d, then we'll have equation of this periodic function from the graph. So here, let's check a lot of thing over here. So first of all, you can see the concavity is from here. That means there could be one line passing through x equals to 1. All right, so that is x equals to 1. All right, so this line is sorry, y equals to 1. So that line is y equals to this line I'm talking of, y equals to -1. Okay, so this line is y -1 because you can see that the concavity has been changed about here. So one thing you are sure is that d value is going to be -1. Now let's talk about this period. In fact, tan function doesn't have a fixed period. It has period negative infinity to positive infinity, which is undefined, but this sort of thing, that is a, we can get it, to try to get it from this curve. So here in this case, you can see that in this curve, if you talk about one complete cycle about the line, yes. So if you see this sort of thing, and from here also this sort of thing, they make one complete cycle. Okay, so this way you say about one half and then another half makes one complete cycle, and here also one half and another half makes one complete cycle. So I'm taking the reference of these two part of curve. So midway point between these 2 points are, it is how many units, because up to here is 2, and then 0, 1, 2, that means 2 units equals to 1. Here this is 1 unit and this is 1 unit and this is 2 units, so this is 1 up to here. All right, so 2 units equals to 1 over here, and towards downward also we have the same thing. So let me count how many units are there. From here to here it is half unit, and then from here to here is 1 unit. So total length for this is half plus 1.5, that is going to be, sorry, half plus 1, and that is going to be 1.5, and midway between 1.5 is divide 1.5 by 2, then that is going to be 0.75. So 0.75, we are talking about the direction left to the about the negative x-axis. So you have to take negative 0.75. So you can see here that this is half, this is 1. So negative 0.75 is somewhere here, right? Somewhere here, then somewhere here, and then count how many unit it is going down. It is going down about half unit to the down. Okay, so it is going towards minus half units to the down, and then from here, okay, and then midway distance between this, if you like to see actually, so we are talking of this line and this line. So this is half, 1, and 1.5 divided by 2 is somewhere here, and half of this is this point, and half of another is somewhere here at this point, and halfway equidistance you find here. So it has moved half units up and half units down about this middle line, y equals to -1. So upside is, if you consider that as positive direction, then upside is, it is 2 again. So amplitude value, you can say that amplitude value is, a value is 1 by 2. Okay, but what happens here, this is the graph of, not the tan x, actually it matches with the graph of negative tan x or negative tan 2x, minus tan 2x. That means coefficient of x must be, coefficient of tan x must be negative. So instead of taking a, we will take minus a. Okay, so we have got this value, and you can also check that what will be the amplitude then. Here in this case, amplitude equals to, you know that if you consider the coefficient of tan function to be amplitude, although the amplitude is undefined here, so the formula that we have used before also is maximum minus minimum point divided by 2. So here you can see that maximum point, it has gone to how many units? This is negative half. Okay, this is negative half. And minus minimum point is how much it is? This is negative half is upside, and then another half is here. That means up to here is 1.5. This is 1.5 in negative sense, so it is minus 1.5. That means 3/2, and whole thing divided by 2. So this is 3/2. You can say here minus 1/2, and negative times negative is positive here. So this is 3/2 and divided by 2. So negative 1/2 and 3/2 is going to be 2/2, and whole thing divided by 2. So these two have been cancelled out, 1. So its amplitude is half, and this negative sign is due to the fact that this is not the graph of tan x or tan 2x, but this is the graph of negative tan 2x. It's like of the graph of that. So we have already obtained now the value of D and value of A. And if you'd like to test the value of D about like maximum plus minimum, that is the vertical shift. We can call it vertical shift or translation along y-axis. So this is given a maximum minus minimum. So maximum minimum, when we are talking of, then we are talking along y-axis. So y coordinate we are talking of divided by 2, and you can see that the maximum value is negative half. Yes, in this curve, in this part of the curve here. So maximum is negative half. This is minus 1/2 plus minimum value. You can see that up to here is 1, and then half unit down. So 1 point, that is 1.5, means it is 3/2, and whole thing divided by 2. Now you can see that it is minus, okay, because towards downward it is minus. So 1 minus 1 minus 3 is minus 4, and divided by 4, and then whole thing it is already over here, and these two values are cancelled out now, so that if you have proper practice of this sort of algebra, so this is no, it is 4/2. Sorry, in the denominator there is 2, so this is 2 1s, and then this is 2 2s are 4. So what you have got actually minus 2/2 equals to minus 1. So value of D is minus 1 by using this formula also. Now we are concerned to find value of B. You can see that value of B is the period for it will give the period for the given tan curve over here. So let's see that as period of tan function is pi, but if there is something in coefficient with x, then that will be divided by B. So here you can see that B will be given by, after cross multiplication, by period. So in this curve from graph, you can count the period from here. So you can see, you can check from here to here, like at this point, this value will go over here. Then up from here and up till here, you can see that this distance is equal to this distance. Yes, can you see? So this distance equals to this distance, and the difference is over here 0 to negative pi/2, or from this side also 0 to pi/2. If you do the same work over here, then period of this graph is found has been found as pi/2. So use the skill in algebra and the fraction calculation. Then these two terms have been cancelled out, pi and pi cancel out, or you can write here after that term it is pi/1 and whole thing divided by pi/2. It depends on you that how you are smart in making calculations easy. So it is pi/1, and then times this is 2 will go up by pi, So this is cancelled out, this is cancelled out. So value of B we obtained is 2. It's okay. Okay, now we are going to find the value of C. What would be the value of C? This C. It means let's check over here. So this is passing through this way, and 0 point is over here, in fact, or if you can consider these two curves. So if there wouldn't be C, that curve will pass through 0 over here, and for this negative 1, -1, it would pass through this point, and it would show asymptotic nature about the line y equals to -π/4, and also towards another side about asymptotic nature about x equals to π/4. But if you compare these two, how does it look like that? So about 0, this curve has been shifted half unit, 1 unit to the left. So when it is shifted 1 unit to the left, then value of C will be +1. So left shifting means we take this value as plus. If that would be shifted right by 1 unit, that means horizontal shift is 1 or 2, then towards right, then we write here minus that value. But here in this case, originally the graph without C looks like it's over here, and now if you compare these two graphs, it looks like as if it has shifted to half, another half, 1 unit towards the left. So if it is shifting towards the left, C value is +1. All right, so let's put back all these value to this equation, and then we'll have y equals to, you can see here, this is A, so A value is -1/2, then it is tan. B value is, we have already here 2, so this is 2, and in place of x we write x, in place of 1 we can write +1. That means 1 unit shifted left along x-axis, and this value D, that means the translation or the phase shift along y-axis is -1. That the curve has moved 1 unit down about its original position. So this is one of the answer. And this is also possible that in order to find the period, so period equals to, you know that period of tan is pi, not 2π. And if something is in coefficient of x like b over here, then it will be divided by b. So the value of b will be equals to pi by period. And this period, again, you can read off from the graph. So for example, if this point these points are given in terms of pi/4, pi/2, etc., then it's fine. We have got b equals to 2. If these are not given in terms of pi/2, pi/4, or pi something like this, then what you have to do, you have to take this value 0, 1, 2, 3, 4, 5, 6. Similarly, in the negative, towards the negative direction along x-axis as well, we have to take 1, 2, 3. So we are considering these two, or any 2 point, this 2 point or this 2 point. Okay, let me count how much it is. So this is half, this is 1, and this is 1.5. So period from this graph is 1.5. So let's see again, this is up to here, this is 1, and up to here this is 1, but up to here this is half only. So this is 1/2, another half, and then this is third half is 1.5. So period in this case is, this is b equals to pi by 1.5, and then 1.5 you can write it as 3/2, because 3/2 is also 1.5, and this sort of thing in the denominator goes up after breaking this after reversing this fraction. So it will be 2π/3. So in place of b equals to 2, you can also use, in place of b, 2π/3. And you can see here that this is 2 and pi is 3.14, something like that, and this is 3, and these two values are very close to each other. That means ratio of 3.14 divided by and the 3 will be nearly equal to 1. That means it is still very close to value of b. equals to 2. So in this way also we can express it. So when you express, so therefore in this case your periodic equation will be -1/2 tan, in place of 2 you can now write 2π/3 and then x plus 1 minus 1. So this is also an answer for this graph. All right. If you like, you can check this sort of periodic graph in a graphic calculator also. So let's see here. In the graphic calculator, I have the graph of this function that we have just read off from the given graph. So graph of this is like this, and the graph of, instead of 2, I have put here π/3. You can see they all pass through very close point to each other. All right, so 2 π/3 and 2 are very close to each other. So either you write answer as this or answer as this, both will work.